All right, we're going to talk about properties of parallelograms. Okay, so parallelogram is a quadrilateral with both pairs of opposite sides parallel, right? That's why it's called parallelogram. Opposite sides do not share a vertex. Opposite angles do not share a side. Okay, so here's our quadrilateral. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So these opposite sides are going to be congruent in a parallelogram. If the quadrilateral is a parallelogram, then its consecutive angles are supplementary. Okay, so these two angles are going to be supplementary. These two angles are supplementary. They add up to 180. So A plus B equals 180. Okay, so what is the measure of angle D? Well, this is a parallelogram, so I probably should have stated that. So if this is 65, I know angle A plus angle D has to equal 180. So this is 65 plus angle D equals 180. Subtract off my 65 minus my 65. Angle D equals 115. So 115 degrees. Okay. If a quadrilateral is a parallelogram, then opposite angles are congruent. So these opposite angles are congruent. And in the diagram, you kind of saw that. A, B, B. Given that this is a parallelogram, prove A is congruent to C. Okay? So the first thing we're going to do is we're going to come up here, statement, reason, A, B, C, D is a parallelogram. Given. Okay. So, well, that's good, right? I'm trying to prove that A is equal to C. So the first thing I'm going to do is I'm going to go angle A plus angle B equals 180. And that's consecutive. Angles are supplementary. Okay? And I'm going to go angle B plus angle C equals 180. And it's the same reason, right? A, B, these have to add up to 180. B, C, these have to add up to 180, right? Same side interior are supplementary. Now what I'm going to do is I'm going to go angle A plus angle B equals angle B plus angle C. All I did was substitution for 180. So I substituted angle B plus angle C for substitution. Now I know that there's angle B on both sides, so I'm going to go angle A equals angle C, subtraction. Okay? So now I've proven that opposite angles are congruent, are equal and congruent. Okay? Theorem 6-6. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So what's going to happen here? AE is going to equal EC. Okay? Okay, so here I want to find DB and I want to find AC given that all these pieces have these variables. So AE is X, EC is Y plus 2, DE is Y plus 10, and BE equals 2X minus 8. So I'm going to set these up. Over here, I have X equals Y plus 2, and I have Y plus 10 equals 2X minus 8. I have two variables, two equations. I already noticed that this one is solved for X, so I'm going to go ahead and substitute anywhere I see X down here, Y plus 2. So Y plus 10 equals 2 times the quantity Y plus 2 minus 8. Y plus 10 equals 2Y plus 4 minus 8. I'm going to subtract off my Y and simplify my side here. So I get Y minus 4 equals 10. So I'm going to add 4, add 4, and I get 14 equals y. Okay? So 14 equals y. Now I can kind of figure out what each piece is. All right? So I know that this has to be 14 plus 2 or 16. This has to be 14 plus 10 or 24. So if this is 16, this is also 16. And this is going to be 24. So dB is going to be 48. And AC is going to be 32. And I know it looks off because this side looks longer, but from our information here, we have dB is 48 and AC is 32. Okay, theorem 6-7. If 3 or more parallel lines are cut off of congruent segments on one transversal, then they cut off congruent segments on every transversal. Okay, so if x and y are equal, then c and e are equal here. Okay, what is 7q plus 3q? Oh, you're welcome. Who invented fractions? Well, Henry the 1/8. So that's looking at different aspects of parallelograms.